yeah, so that is what RAG is in essence. So there are different stages in a RAG pipeline. So we are going to look into the different steps and stages in RAG pipeline. So going forward, I don't know if I'm making sense. You can react to what I'm saying, or if you want to call me back or ask a question. So while we proceed. So why do enterprise need RAG? So just like I said, the reason why enterprise or businesses need RAG is because they need their own source of truth. You don't want to make you don't want to make requests directly to an LLM like ChatGPT or Cloud,
Mm.
which was not trained based on that company's internal
I
documentation.
think say get with you come up for me for here now.
Admin, please, can you help me control the noise? So, looking at why enterprise need RAG. So, most organizations need AI that understand internal policies, customers' documents, product manual, and changing business knowledge. So, RAGs gives the model access to that knowledge without repeatedly training the model. So, and why do we need this? Like I said initially, hallucination. If you go directly to ChatGPT to ask how many leave a staff in one goal is allowed to take in a year, I'm sure you will not get a correct answer because ChatGPT was not trained with that internal document. So one of the problem you are likely to face if you try this is hallucination. So for those who do research, you also find out that sometimes if you use AI tools, LLM or generative AI, to write research. Sometimes they hallucinate and give you citation of a project that does not exist from the top of their head. So there is no knowledge base. The document or information with which they were trained did not capture those cases. So one of the problems we are going to encounter if you try to do this without a knowledge base is hallucination. Then there is privacy of data, then traceability. For traceability, you want to be sure that the information you are getting from an LLM actually exists somewhere. That is why we need a knowledge base for a rack system. I hope I'm making sense. Yeah, so we proceed further. If you have a question, you can drop on the chat so admin can call my attention because I cannot see the chat right now. So going further, if you've ever worked with an AI model, building an AI model that is machine learning or deep learning, you come across fine tuning. So if you pick any AI algorithm, let's say random forest or principal component analysis, and use a particular data set to train that algorithm, you have a model. So when you get the efficiency of that model which you've trained using a particular data set, maybe let's say you get an efficiency of precision of maybe 75% or 80%. Fine-tuning is getting more data to train it to see if the precision of that model will increase. So, and to do this, you need to repeat the process for all of the model. So the difference between this and RAG is for a RAG system, you know where the source of truth is coming from. But for an answer from a model or through fine-tuning, you cannot trace where that answer is coming from. Most times LLM behave like black box. Sometimes they cannot give you citation of where they are getting their answer from, except you probe further or you prompt further. So this is some of the difference between a RAG system and fine-tuning a model. So going further, we want to look at one of the key features of a RAG system. So a RAG system, unlike other system or the traditional database, so one of the differences is that For a RAG system, it uses what we call semantics. So your traditional database or query, when you write a query, it searches for keyword. It does keyword match. If you write a query to check for maybe customer database for a customer called Jonathan, or if there is a business, if there is a branch in Lagos, what is going to be checking for is it is going to be comparing keyword to keyword. The keyword you are using to query the database, it's what is going to check to see if it exists in the database. But for semantics, which is what RAG system makes use of, it is going to check for meaning. So it is not checking for keyword. It's not doing keyword comparison. If it exists, return an answer. If it doesn't exist, tell us we did not find a particular match. So for a RAG system, we make use of semantics. It compares meaning. For instance, if you build a RAG system, do your cleaning, chunking, embedding, and store to the database, and you decide to query. Let's say you search for a vehicle. It is going to, if there is SUV as part of the chunk, it will return SUV because SUV is a close match to a vehicle. If there is a car, maybe Toyota or any model of car, it is going to return it. But for a traditional database or a system built using a traditional database, what is going to search for? If you search for a vehicle and there's no vehicle in the database, it is not going to return any answer for you. So this is the difference between traditional database query and semantics, which is what a RAG system makes use of. Okay, so looking at a RAG system architecture end to end, like I said initially, so you are going to have a source, which is the knowledge base. So the knowledge base can be of different form. It can be a PDF documentation of a particular business unit. Maybe for a bank, let's take bank for example. You can have a loan unit in a bank. So there's going to be a document around all the steps. Who is qualified to take a loan? How long is the maturity date to start paying interest? All this information. So you can chunk this information, break them into smaller units, then embed them in a vector database and use them to build a RAG system. You can also use a Word document, which is not PDF in this case. You can also use a website. You can scrape information from a website. For the demo I'm going to do later on at the end of this section, you are going to see. So I made use of a website article to be specific. So I used the URL of the different articles to build a RAG system. So you can use API, you can use websites, URL, you can use PDF, like I said earlier. So any document, any form the document exists, you can use it as the source. So the ingesting part is you have this document. So how do you get it into your database? So that is the ingesting. And to do ingesting, you need to clean that data. Let's assume in my case, I made use of a website, an article that exists in a website, NHS website. So I don't want if you're a software engineer or you've worked with HTML before, you see that every word in a website is inside an HTML tag. And if you want to ingest those words into a database, you need to clean that the information you are getting from it because it exists inside some HTML tags, anchor tags, and the rest of them, the body, H1, and the rest of them. So you don't need these HTML tags. What you need there are those words that have meaning, that is in relation to the context of the particular unit you are dealing with. So after doing the cleaning, you need to do chunking. You cannot carry, let's say for instance, a PDF of the steps to seek for a loan in a bank. Let's say it is 250 page. You cannot carry the whole 250 page and store in a database. If you do that, if you want to do a search, it's going to be very difficult. So in that case, that is where chunking comes in. You need to break them into small units that will be able to be indexed and search quicker. So the chunking simply means breaking of the source of truth, whichever source of truth you are using, either a website, an article, a Word document, PDF. You need to break each page into smaller units. And later on, we are going to see where you do overlapping because you want to retain the information inside those chunks. You need to do overlap so that each of the chunk will still have a meaning retained after you've cut them smaller. So the embedding, which is also one of the strong feature in a RAG system using vector databases. To be able to do semantic search, you need to do embedding. Embedding is converting a text into a vector space. So let's take I gave an example earlier of where you make a search in a vector database for a vehicle, it can return a car for you. If you do that in a normal database, it will not work because a vehicle and a car, the text does not match. There's no relationship between them in terms of the word. So how does the vector database do this, or how does this happen in a RAG system? So that is where embedding comes in. So it converts that plain word into a vector representation. So that is what embedding simply means. So that is the point of ingestion. These are the things that happen during ingestion. So what about when you want to query or seek for a particular information? So what happened? So you are sending a plain text. For example, how much loan can I get for a business that make maybe 20 million per year? If you ask that question, of course, that is a plain English word. You cannot compare a plain English word and an embedded word in a vector database. So you need to convert the query you are sending as well to an embedded form before it can go to the database and retrieve an information for you. And when you get this information, that is when you can use it as a prompt for an LLM. That is where LLM comes into the RAG pipeline. After you've gotten the answer you want from your whichever vector database you decide to use. I use Chrome in my own case. So when you get that response, which is the retrieved information, you use it to prompt the LLM alongside the question you asked. So the LLM will polish the response you got from the vector database and give you a generated answer. So a RAG is a retrieval augmented generation. So the generation is talking about the response you are going to get from the LLM. So I don't know if I'm making sense. Do you get what I mean by some of these terms using a RAG system? You can react if you're following. Okay, earlier I made mention of the source of knowledge source or knowledge base here. So these are the different knowledge base. So the knowledge base can be in form of PDF. It can be SharePoint. It can be from a website. It can be an API. It can be email. It can also be from a database. You can ingest directly from a database as your source of truth or your knowledge base. So these are the different source of truth that a RAG system makes use of. There might be others outside this, but for now, these are what I could come up with. I don't know if you have anything in mind that you think can be a source of knowledge source. Yeah. Okay. So I go further. So did Shay, I think someone raised his hand. Shay. Yeah, you can go ahead with your question.
Yes, thank you. I just want to add, can we get information from social media, maybe linking into social media platforms?
Yes, exactly. That is social media is same as maybe website API. Yeah,
Okay,
so
thank you.
yeah, you can scrape maybe Facebook, Instagram, Twitter. Some of them, although some of them is they prevent that, or if they find out you are using a bot to scrape their site, they will ban the account you are using to do the scraping. So, but yes, you can scrape any of those social media sites and get those information from there as your source of truth. So the data ingestion workflow. So okay, the ingestion workflow is part of the what I've explained earlier, which involve data cleaning. You extract, store the information you want, and index them, and you store in a database. So in this case, we are using a vector database because, of course, what we want to store is embeddings, not the raw text. So that is why we are using a vector database for a rack system. Is there any other question before I move forward? If there's no question, I'll proceed. So the cleaning pipeline. So to clean the source of truth, I've used a website. I've given an example around using a website. So you remove the HTML tags, the headers, and consign the information we are dealing with. You remove it. Empty space, you remove it before we chunk them, because if you leave any of this wanted information, they are noise. They are going to affect the embedding when we convert from a plain text to a vector space. That is why we do cleaning. So we do cleaning, remove duplicates, then validate, and then after cleaning, so we do chunking. After cleaning, the next step is to chunk the source of truth. So let's say we have a 250-page document, PDF or Word document. So we cannot store this 250-page document directly into our vector database, because if you do that, to search through it will take a lot of time. We want to do indexing so that it will be quick to retrieve information. So we don't need to go from page 1 to page 250. Imagine you are searching through a book without the index. Most books have index at the back. So you can go there and see the title of what is each page talking about, or what is each chapter talking about. It is quicker to search through that instead of moving from one page to another, going line by line. So it will take a lot of time. So that is why we do chunking for a rack system. So we want to be able to also there is to do embedding, there is a number of token that it's allowed. So if you, for example, there is amount of word you put in the search in the input box of ChatGTP, it will tell you the word is too long. I'm sure you've noticed that before. So that is a token in place. So there is amount of token that is permitted to use for embedding. So if it is too long, it becomes a problem. So it will affect the context. When the response is coming back, it will be too long for the context used to build that model. So after cleaning, we do chunking. Then after chunking, we look at the semantics. So in this case, like I said, what we are doing is semantic chunking. So chunking is a strategy that determines whether the retriever returns fragment that contain complete meaning or confusing piece of complete text. So there are different type of chunking. So there's a fixed size chunking, there's recursive chunking, but we are using semantic chunking. So we are going to split um, our information, maybe the website, the article I use in this case, we are going to split the pages in a way that we'll be able to retain the meaning. So if you want to build your own rack system, if your source of truth is a PDF, a Word document, or you are scraping a website and using it as a JSON, storing it as a JSON to use for your source of truth, you are going to put the chunking, the type of chunking you want to use. So in this case, I use the semantic chunking. Okay, when we do chunking, we are breaking, let's say, a page of a PDF into smaller unit because we don't want to store that complete page. So let's assume the first 20 line of the page contain a vital information. Then the second half does not contain the vital information. Then the remaining part, we want to divide into three. We want to divide a page into three. But how do we retain the meaning of that complete page in each of the chunk? That is where chunk overlap comes in. Let's take, for example, so you have chunk A. Without overlap, you have chunk A. The customer may request a refund. Chunk B, 30 days of purchase. So the question is, how many days can it take to request for a refund? Maybe a particular page contains information on how you can request for your refund. So, and you decided to do chunking, like dividing the information into smaller units. Then the first part of the chunk says the customer may request a refund. You broke it down, and the second chunk contains 30 days of purchase. This is without overlap. Now, with overlap, you want to retain the meaning in both part of the chunk so that when you do, when you make a search, it can return both of them for you. So to do the overlap, the first chunk, we have the customer may request a refund within 30 days. Chunk B contains refund within 30 days of purchase. So if you look at chunk A and chunk B, there's an overlap of 30 days in two of them. So this is where overlap comes in. So you want to make sure that each part of the chunk contains some information that will make the retrieval to still have the information of that complete page. So that is where overlap chunking comes in, and that is the technique I used for the rack system I built. Do you have any question? Is there any question before I proceed? If there's no question, I will move ahead. So embedding, like I said earlier, so embedding simply means converting the plain text from the maybe English or any natural language to a vector. You want to convert from a plain natural language, English, Yoruba, Igbo, Chinese, Portuguese, French. You want to convert it to a vector because using in the vector space, related words stay closer to each other. So when you make search, you'll be able to return words that are closer to each other. But in the human language or natural language, if you search for two things and there is no word, relating word between them, then the search will return empty, or it will tell you that a similarity does not exist. For example, you search through a database, there is a car in the database, and what you search for is vehicle. Semantically, there is a relationship. A vehicle, car is a type of vehicle in terms of semantics. But because the two word does not contain the same word, or in the sentence, you can decide to use a word or a sentence. There's no relationship between them in terms of character match. So in a traditional database, it is not going to return anything for you. But if you convert the words, if you embed them and convert them to a vector, So you see that their representation will be closely related. So in such a case, if you make a query for a vehicle in a vector database that contains car, it will return a car for you. So that is what embedding does. So once text become a vector, the system can compare semantic similarity using distance calculation. So going further, so this is embedding vector space. So if you look here, vehicle, automobile, car are are close to each other because in the vector space, their vector representation is close to each other. So that is why they are close to each other. If you look at policy and this other word, where is okay, let me see if I can read this. Okay, policy and regulation. So policy and regulation are close to each other because in terms of semantic, their meanings are similar. So banana is far away from two of them because the meaning does not in any way relate to this or this. So looking at this example, let's say a user asks, how do I train my puppy? And in the vector space, we have dog training. If you look at this character of string or this word, there is nothing like dog in it. So it asks, how do I train my puppy? But we have dog training here. So because the semantics of this word and this is closely related. So when you search for this, it will return this for you. If you even replace this training, because I can see train here and training here, it will make it look as if the words match each other. If you remove training and use any word here that gives the same meaning of training a dog, or how do I make my dog behave, it will still return. If you search for this and our vector database contain how do I make my dog behave, a search for this will return that particular chunk. So that is how it is represented in the vector space. So the vector store design. So like I've been saying since the vector database store embeddings. So the document reference, metadata. So the metadata, you'll be the one to give this metadata. Maybe in when you convert to embedding, you want to add maybe what you are storing might be user information. So you want to add maybe user ID as part of the metadata you are storing on the vector database. So all this metadata will be decided by you, but the conversion of the word from natural language to vector space, there's a model that handles that. So that is what a vector store in the database. So we have different type of vector database, which you can look up later. So this visualization of vector store. So when you search for a particular word or statement, so it looks for the closest relating word. This is another word, but this is very far from this one. So this one's in green are closely related to the search statement or word. That is why they are close. So they are showing green here. So these other ones that are far from it, which their semantics does not correlate, are in white. So this is just a visualization of how the database behave. So retrieval workflow. So let's assume after the whole ingestion from cleaning, chunking, embedding, and storing to a vector database of choice. Now, you want to query or you want to ask a question based on your knowledge base or your source of truth. So what are the steps? What happens? What are the different stages it takes to be able to get back a response for you? So this is the workflow. So when you ask your question in a natural language, English for an example, it converts that your question, which is a query, to an embedding. So the vector database, we now compare that embedding, which is has been which is your question, which converted to vector representation. It uses to query the database to see if there is any chunk that is closely related to it. So let's assume we have 20 or 50 or even 1,000 closely related chunks to this particular question you ask. So how is it going to return the right answer for you? So that is where ranking comes in. So it does what we call ranking. So the ranking is between 0 and 1. So it checks which one is closely related. So depending on the amount of ranking you program, if you want it to return the highest ranking word for you, you specify the ranking as 1. If you want it to return the top 2 ranking, the two closest information in the vector database to you, it will return 2. If you want it to, so any number, the number is user defined, so you can customize it to any number you want. So that is how the workflow works. So when it does the ranking, so it will use that retrieve word. So you can build a RAG system without integrating an LLM. It will still work. But the generation there, which is the last word in the RAG, has been omitted. So you're no longer using LLM or AI in this case. So your whole feature is depending on the intelligence of the vector database, the embedding and the chunking. But if you integrate an LLM, so the response you get from the vector store, you will use it as a prompt to prompt the LLM. So it is going to refine this response you get from the vector database and give you something meaningful, more meaningful than the chunk. So the chunk might be very short. So what the LLM does is to make it more comprehensive than it is in the database. I don't know if I'm making sense. You can react. So moving forward from retrieval workflow. So we have different type of retrieval. So there is dense retrieval which captures meaning, and then there is sparse retrieval which captures keyword. Of course, I've been saying we don't for a RAG system we don't capture keyword or we don't search for keyword. What we search for is meaning. The closest meaning to what we are searching for is what we want to return. So that is how. So we are making use of the dense retrieval, which captures meaning in this case, not the sparse retrieval. So unlike traditional database searches where a keyword match is returned, hybrid retrieval combines meaning and keyword. So we are using hybrid, sorry. So a combination of both. So if it sees a correlation between the search keyword and what exists in database, it returns it. If it is the meaning it sees, it returns it. So going forward, so context, assembly, and re-ranking. Yeah, this is relating to what I explained earlier about using an LLM. So when you make your search and there's a lot of chunks related to the query you make. So it is going to re-rank them and remove duplicates, then return the top ranking depending on the number I want. If you want to return top 3, in my case, I use top 3. It can return top 3 for you. If you want to return top 2 or even top 1, it can return. So that is, you can customize it to any number. It is a constant. So you put the number you want there as the ranking. So generator layer is the LLM we are making use of. So when you get, like I said earlier, so when you search or when you query a vector store with your question, and it retrieves an information for you. You want to send the retrieve context as an input into your LLM to get a grounded truth or information. So what the LLM does in the RAG architecture is to make the response you are getting, which is a chunk, shorter form of a complete information. So the LLM will help you to make it comprehensive. So let's say you ask for how many days does how many leave, yeah, is a full-time staff allocated or allowed to take in a year? Because you've done chunking, one part of the chunk contains only 30 days. And when you queried your vector database, it returns only 30 days for you. So if you send these 30 days to the LLM plus the question you ask, to be able to refine that 30 days and give you a comprehensive information as a response that for a full-time staff, you have 30 days leave in a year. So that is the role an LLM play in the RAG pipeline. So prompt augmentation for grounded answer. Okay, yeah. This correlates to the explanation I just gave. So let's imagine, suppose your knowledge base contain the maximum loan amount is 50,000 pounds, and a user asks, what is the maximum loan amount? And the ground truth answer is 50,000 pounds. So if you give this 50,000 pounds as an input to an LLM, plus the question you ask, what is the maximum loan amount? The LLM will be able to translate it and make it comprehensive. So the answer you are going to get, instead of just 50,000 pounds, which is what your vector database gave as an answer, the LLM will help you make it comprehensive and return 50,000 pounds is the maximum loan amount. I don't know if I'm making sense. So I'll proceed further okay, enterprise case study. So the different applications of a rack system. So you can use a rack system as a customer support. So the system I built, which I'm going to demo briefly, is around customer support for NHS. So it is used internally for staff members around their loan. So staffs in NHS can have varieties of questions around their pension. So, and the system they use currently uses the traditional database architecture where you do word match. So the customer support find it difficult to do this search. Let's say they have like 200 different articles that explain the different information about pension in NHS. So as a customer support, you need to have like understand the keyword you need to query to get this response. So each time you're on call, maybe one of the staff of NHS calls and asks, how much am I entitled as a staff for my pension? I've worked for maybe 20 years or 16 years. You need to know the right keyword to search the existing system. But with a RAG implementation, you can put any word that closely relates to the question that staff is asking, and it will give you all the answer related to that specific question and the links where that employee can go and read about the information. So the problem with the existing system is that new employees, new customer support in NHS find it difficult to understand and use the system. So it takes them time to learn and understand the right keyword to use. So the onboarding process is longer. So a RAG system bridge solves this problem. So I'm going to demo something similar to that. So that is one of the enterprise use case of a RAG system. And this customer support, of course, every company needs customer support because they have information relating to them. MTN, over the years, they have a bot on WhatsApp that you can chat to, but it is not intelligent because if you ask any question outside what it was programmed to do, I don't know if they've changed the implementation now, but the last time I used it, if you asked any question outside what it was programmed to do, it will try to take you back to maybe suggest some keyword that you can ask. So for a RAG system, it is that intelligent that you don't need to use the correct word to query it. As far as the meaning, the semantics are related, it will give you a right answer. So you can also, in banking and compliance, you can also build a system, a RAG system around banking and compliance. A financial institution can use RAG to retrieve policies, regulation guideline, audit procedures, and customer service rule with source grounded answer. Of course, the grounded answer means this answer is not coming from the sky or from an LLM, or it was not manufactured. It is coming from an internal knowledge base. So it was not manufactured. So a RAG system can be used in almost every sector. Every sector that needs customer support or have internal document that can be used as a source of truth. You can implement a RAG system around that to make the usage faster. That is the whole essence of a RAG system. What is supposed to take maybe 2 minutes or 3 minutes to do, you want to, with just one prompt or one search input, you want to get a quick answer. So another enterprise case study is the healthcare knowledge. So you can use the RAG system in the healthcare sector. Yeah, just like banking and the other ones. So these are advanced RAG implementation. So it is called Graph RAG. We are not looking at this. So there is agentic RAG where you use AI agent, not just an LLM. So maybe you want to call external API or do some reasoning before the search takes place. You can do the implementation. Then RAG evaluation, yes. RAG evaluation is very essential in the sense that you can build a RAG system and admin. Can you help me mute this person? Okay, RAG evaluation framework. For anything that is related to AI, there is a need for compliance and checks, regulation to be specific. So imagine building a customer support system around pension or around loan, and someone is able to put a prompt on something different from what that system was built to do. And because it is connected to an LLM, it will still give them an output. It is not supposed to be so. So you need to checkmate everything you are doing. So every answer it is giving should be correlated to what it was built to do. That is the essence of the evaluation. So it should be properly tested before going live. Yeah. I don't know if there's any question you can ask before I do the demo for like 5 minutes.
Thank you, Mr. Jonathan. Okay, so I know that one of the major constraints with these LLMs on this RAG is hallucination. right? And put it in, maybe tell them something and they just kind of, I don't know, maybe like a drunkard, tell you something different, right? So
Yeah.
how do we solve against that? Yeah.
Okay, to prevent hallucination, I'm going to show you there's what we call system prompt. There's user prompt and system prompt. You can implement a system prompt and tell the LLM that do not go outside the scope of this. So if you are building the system around banking and loan, you are going to include a system prompt internally that goes to the LLM with the user's question, telling it if you don't know the answer, do not try to manufacture your own truth or create something that doesn't exist. Just say you don't know it. So that is what system prompt helps prevent hallucination. So it will tell the AI, do not manufacture any truth. If it doesn't exist, tell us it doesn't exist. If you don't know the answer, tell us you don't know the answer. I don't know if that helps.
That helps. Thank you so much.
Yeah, you're welcome.
Yeah, Jonathan, can you hear me?
Yes, I can hear you.
Yes, I think this is very interesting. My question is around the enterprise use cases. I know your attention has been around the customer service. So based on what you have explained now, does this have any application, any use cases around the inventory management, especially as related to products?
Inventory management relating to product, like you want to know if you still have so amount of product remaining or there's a need to make more order. Is that what you mean?
Yeah, exactly. Is there any way we
Okay.
can deploy like this particular innovation around it?
RAG system does not work in that sense. What RAG system does is it works on information that doesn't change regularly. So if the information changes, you need to update the source of truth, which is the knowledge base.
Okay.
And
So
you
at the
know
moment, it's
for
only around the customer service.
mostly around customer service. To be specific, one of the things RAG system works as a chatbot, customer service but it is more intelligent than a chatbot. So if you want to implement an AI around inventory system, there are other ways you can do it, but not with a RAG implementation.
Okay, thank you.
Yeah, you're welcome. Sheyi, I think your hand
Yeah,
is
yeah,
raised.
yeah. I also wanted to add to what Dr. Nami just said. Because he talked about the way retrieving information from database, right? Which is one of the way to get knowledge. So, when he asked questions about the inventory management, I was thinking, what if you have a database that stores your inventory, right? And then you get information from there.
So this is okay. Yeah, it is possible. So, but just like I said, there is going to be constant update. So you are going to be streaming um, events from that database. So each time you sell a product, you want to update the rack system source of truth. Do you want to do that?
Because I'm thinking from an enterprise perspective, right? Let's say, for example, you want a very big company, right? I
Mhm.
think there might be maybe a dedicated person that probably every morning or every week there's like an automated update. Probably on maybe using Airflow or AWS platform where there's an automated Airflow dark process that automatically updates the LLM and the database or whatever you get. So I'm just thinking about that. Yeah.
Yeah, if you can implement a process that constantly updates the vector store, which the rack system makes use of, yes, that implementation is possible. But if you want to use a static document, like let's say a company drafts their rule around maybe seeking loan or internal memos about the rules of a company, maybe how many leave you can take in a year. Maybe we work hybrid. Like some of this information now, you know, is not going to change in the next 6 months. So that is where RAG system comes in. But if you want to implement a system whereby like an inventory system changes frequently, because as users are buying products, you want to be updating the inventory. So you are going to do something like streaming around it. Yeah, it can work, but that is not the best use case for a rack system.
Okay, thank you.
Yeah. Is there any other question? Wow. If there's no question, I will quickly want to demo something I did for NHS. It has not gone live. So it's using a RAG system anyway. So let me stop presenting. Can still see my screen. Okay, so this are the so I used 41 URL. So these are different articles about pension in NHS. So this is my source of truth, or my knowledge base, rather. Your screen sharing is paused. Oh, uh, can you guys see my screen?
No, I can't. I can see your screen, but it's still on the questions on the bottom.
Okay. I think I need to stop sharing and share again. Okay, I was the one who made the mistake. So I was sharing, instead of sharing my whole screen, I was sharing one screen. Yeah. Let me share my entire screen. Okay, can you see my screen now?
Yes.
Yes, we can see.
So I used so in NHS for the pension access system they're using presently, they have like 200 different articles relating to questions their staff can ask. So I used 41 of it to build a demo I want to do with them later on. So these are the links. So I'm going to, so of course, if you look here, you are going to see the different, the chunking, cleaning, the pipeline, the source, the retrieving, the vector store. So I use the Chroma database. It is a type of vector database. There are other ones. I think Postgres to have the ability to store embeddings. So you can look them up. Then this is the backend using Python. So there's the front end of it, which was built using React. So I'm going to run the backend and the front end, then demo how it works. So I'm preparing the URL for chunking. So I'm testing if the URL are working. So that is why you're seeing the 200 OK, the HTTP response. So this is fine. The Python, I used Fast API framework, is a Python framework to build this API. So it is running on this port 800. So I'm going to run the front end. So it's running here on local hosts. So yeah, this is the user interface. So I'm going to run the ingest. So we have 41 URL, but at the end of the chunking, we are going to have like 133 chunks. So that is like dividing each page of the article into like 3. Sorry. So ingesting 41 article, 133 chunks indexed. So if I want to ask, I can ask any random question about NHS pension. Then you are going to see the ranking, how related it is to what it is in the database. So for this system, Sheyi, you asked a question about hallucination. So I've not handled the hallucination on my vector database. So I can ask question outside pension and it will return a response for me, but you see the ranking is very low. I'll demonstrate that. But let me start with this. How much do I contribute to NHS? So this is the score. This shows this is highly related to what we have in our vector database. So the question is, how much do I contribute to NHS? This is the explanation. So currently, all employers will pay 14.38% of their earning as pension in NHS. So this is this, this 0.2, close to 1. This is after this score, the next one is 0.5, the next one is 0.58. So how I did the implementation is, when we get the answer of what we search for, we can send URL to whoever make this inquiry. So this is how a customer support is supposed to work. So if you call me and make inquiry, I should be able to send you a link to further read about what you asked if you think my explanation or the answer I gave you is not up to what you are seeking for. So if Sheyi can give me his email, I will send this information to Sheyi and some write-up. Yeah, you're raising your hand.
I'm sorry to interject. I was thinking because I saw the way the response came out. I was thinking it was gonna be personalized. Maybe that kind of you contribute this and this and this, not coming as a statement. I'm just
So
this the way when you use LLM language like GPTs, right? It comes out in personalized and formal, like okay, you need to do this and stuff. So I'm just thinking, is there anything we need to do, or there's another step to get to that?
excellent question. The reason why this is behaving this way is the LLM key I'm using, the API key, ChatGPT API key I'm using is not working. So everything you are seeing here is coming directly from the vector store. So the generation, the optimization of the response is not happening here.
Oh, okay, I get it.
Yeah. So it is not comprehensive because the part where the LLM is supposed to make this answer comprehensive is not working.
Okay.
Yeah. So if I send this response to ChatGTP or any LLM I'm using, it will refine it and it will make more sense than this. So there is also implementation to send an email. Now, let me show you example of hallucination. So this score shows it is highly related to what we have in our knowledge source. Now, let me ask something that doesn't make sense, that is not related to pension. Because I've not handled that case, it will still give me a response, but far related from what we have. Did you see what is happening here? So if you see what is happening here, this is the score. So I can do a check. Any score less than 50 shows, of course, it does not correlate with the search I did. Anything outside pension, NHS pension. Okay, let me show you the what is it called? The system prompt implemented. System prompt is in the generator. This is the system prompt here. Like I said, this is not connected to an LLM yet. So, but this is supposed to handle hallucination when we interact with an LLM. So I'm supposed to also have a system prompt that works for the vector database, so that any prompt that is outside NHS pension should not even go to the vector database. That is why you are seeing this response here. This is supposed to tell us that this system does not handle anything outside NHS pension, because this is lottery, and this system is supposed to deal with NHS pension, and somebody is asking about lottery, and it is returning a response for us. These are different evaluations I can do around this system. Yeah, so that would be all for me for today. Thank you very much. So anyone that is interested in the code base, you can reach out to me. I can share the code base with you. Then you can modify or rewrite it to any use case you want to do. It's on my GitHub. So yeah, I can give access to it. Thank you
Okay,
very much.
can I, Jonathan, before you close, I want to commend you for this excellent sessions. And I also want to also encourage our participants. This kind of live project you see if you're enrolling our program. So if none of you find any of these sessions interesting, I would advise encourage you guys to enroll with us, Wongo Analytics. Currently, we are running 2 sessions: the cybersecurity and data analytics. So Jonathan is one of our key instructors. If you find this interesting, it's one of the major components of our live projects. So I encourage you guys to enroll. The website is there on the chat box, and I'm sure you're going to learn more. So thank you, Jonathan, for this wonderful demonstration.
Thank you.
I really enjoyed myself. Thank you very much for this effort.
Thank you. Chinenye, yeah, you can ask your question. Is it Chinedu?
Great,
Sorry,
sir.
not Chinenye.
Yeah, teenager. My name is teenager. Yeah, no problem. So thank you, sir, so much, sir, for the session. So I want to ask, would it be possible for us to get your slide so that we can, go through it anytime we want?
Yeah, you can go through the admin. I will drop the slide with the admin, and through the admin, you can get access to it if the team permits that. Yeah. So reach out to the admin. Yes. Is there any more question? I can see some chat in the chat box. Please, which stage of the development is the hardest working on? Okay. Who, this Xiaomi, the name is not here. Okay. The stage of the development that is hardest is learning core programming fundamentals, because I've explained the theory behind this, and I believe everyone understand that you need to get data, clean it, chunk, embed, and store to a database. Then before you can write, make a query to the database, then the output, you send it as a prompt to an LLM. But to be able to do all this, you need to learn programming. Maybe you can do this with Python or Java, or I don't know if it's possible with C Sharp, but I know with Python and Java you can do this. Then you also need to learn a front-end language, JavaScript. So you'll be able to use, you can use plain vanilla JavaScript with, is it possible to make API calls with vanilla JavaScript? Well, I know with React, you can do that with React, Angular, or any other JavaScript framework. So you need to learn programming to be able to implement this. Then have little knowledge of AI. There's no much knowledge of AI needed here, because what you need is just to make an API call to an LLM, send your question, then get the response, then output it. So you need to learn programming. That is the hardest part of it. So if you know how to code, you should be able to build this. It's not that complex, but you need to learn how to code first. Yeah. And this is one of the things we offer at One Goal Analytics, as Dr. Namdi said. Yeah, any other question, or we can drop it in. Okay. I think there are no question. So let's have a wonderful evening. Thank you very much for attending. I hope to do this again. Yeah, thank you. I'm also on LinkedIn, so you can reach out to me. You can connect with me on LinkedIn and see some of the things I do outside programming, and maybe we can catch up later. Yeah, Jonathan Godson Chudubem is my name on LinkedIn. Thank you very much.